will switch to English. I hope you're good with that at the end of the day, but it is what it is. Okay. AI.
Woo!
AI. So just let's raise the atmosphere here. I want to see everyone raise their hands. Who used AI in some form? Everyone, come on. Okay,
I used AI for this talk, so.
Me too. This is AI.
So your time to leave. If you're not interested into the whole AI stuff, this is the moment to leave. Otherwise, welcome.
Definitely. So this talk will heavily focus on AI. We believe it has the potential to fundamentally transform how we build and operate our IDPs. We're not going to talk about what is platform engineering, what is IDP, because you had the entire conference for that. We will dive right into how we can transform our IDP. And in terms of AI, we see at this moment like two approaches for like how do we think about AI. So one approach is this.
Yeah. So probably you are in one of the groups, like in this case, to say AI, it's snake oil. Snake oil terms means it's something made up, people grifting around this topic, and it's not something you will use for serious stuff. You know, yeah, I can do my Studio Ghibli pictures and so on, but AI will never come into the real world I'm using day to day. Or
another approach is basically you probably use the AI to generate a lot of things like this or even this, okay? So a lot of people are using Agent AI to produce things, and AI definitely reached mainstream.
But on a more serious note, and now we come to the first bold statements you will hear and read here during our talk, is we believe that ignoring AI at this point in 2025, it's not like caution waiting, like I don't want to be the early adopter. Ignoring it right now is pure denial, because here comes my explanation for it. Most likely, your competitor is not ignoring it. Either they started to work to enhance their product, their internal processes with AI, and this gives them a competitive edge over you. And at the end of the day, we are all competing maybe in the same space. So,
definitely. So, in this talk, we will look at the practical, concrete ways to augment our IDP with AI capabilities. And whether you are skeptical about AI or enthusiastic about it, what matters in our day-to-day is delivering value. So we will see how we can build platforms that actually deliver value, and AI can definitely help us achieve that. We are at a turning point, I would say, that AI could definitely revolutionize developer experience and operational experience, and this we will dive about it in this talk. So first of all, let me introduce my awesome co-speaker here. This is Engin Diri. He's a senior solutions architect at Pulumi. Pulumi is a company that allows you to create infrastructure as code with various programming languages. Those of you who don't know, he's actually learning Hebrew because he loves Israel. He's learning with a teacher, okay? So he knows a bunch of words by now.
אני רק לומד עברית בגלל קונה ואוכל שווארמה, סביח. רק בגלל אוכל. Okay, let me introduce Hila. I mean, probably you should know her. She's one of the grand dames here in the DevOps scene in Tel Aviv. She recently started working at AWS, so that's very interesting. And yeah, that's Hila, and yeah, let's.
Awesome. So,
okay, so continuing with our bold statements. So we have again here a bold statement, and we say, okay, classic IDPs, so all the stuff you probably heard or work and so on. We say classic IDPs have a problem by design. So let me bring up some points we found very valuable to explain why we come up with this claim. So one of the things is we still need to write code. That's one of the things. And we believe that code is not an asset for yourself. Every piece of code you're writing, it's a liability. So one of the things, still writing code, you need still maybe creating your own. When you do a DIY IDP, you maybe create the front end and all the stuff, the back ends on your own. So this is a liability. And now comes the next point why we think that IDPs have a problem is also we need to glue a lot of moving parts together. So let me show what I mean. So this you probably know, and this is also because I show this in every my talks, and I think the CNCF will never accept me as an ambassador. Because people see this as a one-shop solution, like a shopping cart. My former manager did this, hey, we need this tool and this tool. Nothing wrong with this. Each tool of them are very nice tools, and there's a reason why they are in the project status. But this is not an integration landscape. It doesn't mean that tool A and tool B work very well together. So you end up probably writing a lot of glue code to let everything work together and keep working on this glue code, because there's a new version, Crossplane 2.0, maybe breaks all the stuff because they don't use claims anymore. So yeah, have fun to work on this stuff.
And because we have a lot of integrations and a lot of tools, domain expertise is always needed. Even with the best self-service capabilities and documentation, someone is bound to say, hey, we need to talk with the platform team. It is what it is. So it doesn't mean that your IDP is a failure, it's just the reality of complex systems. So this dependency on domain experts creates bottlenecks, slow down the development, and creates also frustration in the development teams and the platform teams. And this is where AI could help us bridge the gap. So we believe that, and the pure notion here is that IDPs should be pure agentic based on AI agents, and we will talk about it more in a bit. So when a developer needs a certain X to do something, the platform should be able to understand the request, validate it against policies, execute actions, handle errors, and of course, communicate the status back to the user. And this isn't just about automation. It's about creating a system that can reason about the request and take appropriate action to fulfill the request. And it's just like a well-trained platform engineer would do. So,
okay. It's important to also mention here, we're not really denying the fundamentals of the platform. You know, we'll see this now in the next slide. There was already work done from the CNCF working group around platform engineering, and they created here the so-called capabilities of platform. So this still holds true also in our approach. We talk here, we say, okay, this is fine. We have here the different layers. We have the platform interface, the actual capabilities from infrastructure provisioning to providing scanning, security, and all the stuff. Please have a look. There is the link, and you will maybe see this also in the documents we provide later on. Have a look if you did not saw this, and you can also participate in this working group if you want to bring your input in. Okay, this stays. So let's have a look now how we call it now. We say an AI-augmented capabilities of platforms. So what we say now, let's think about the blocks there and say, okay, let's attach to each of the block, we call it now AI thingy, okay? We call it an AI thingy. And they are all now owning one of these blocks. And like in real life or in marriage and so on, you always need somebody who gives the calls, or in your workplace, your boss, and we call them the big AI boss. So the big AI boss is the person who's going to talk with the user. The left side is still the same. User comes in and expects a response. And the big AI boss is like, okay, and then we see the AI things. And now let's continue this. Yeah, you can go to the next layers. So boss, and a whole Muppet show of different AI thingies.
Different. So, might of you might say that, okay, I want to augment my IDP with AI capabilities, so I can just throw ChatGPT to the race, insert it, incorporate it, and that's it, right? Not quite. So, although ChatGPT does have some agentic capabilities, like it can make API calls, retrieve data, go and do web browsing in order to retrieve up-to-date data, it does lack some true agency. So it cannot do autonomous actions, it doesn't own anything in the process, and it cannot execute anything. So basically, ChatGPT is still primarily a responder. It is not a doer. It cannot execute your code. It cannot fix your production issues. So the thing is that we need an AI workflow that can actually execute and own platform operations and not just suggest them like ChatGPT does. So let's call, Engin mentioned AI thingies. So what are these AI thingies? These are basically AI agents. So it is an autonomous AI-powered component that can sense, decide, and act autonomously to achieve a specific goal. Think about it as a digital expert that can do a specialized capability, like in terms of what we showed before. It can create infrastructure, it can go and get documentation or even generate documentation, the whole works. So it has independent decision-making mechanism, so it perceives the tasks, it has the reasoning mechanism that allows it to understand the task that you give it in free language, because it is LLM after all. So it understands the tasks, and then it checks against the tools that we defined that the agent has, what can it do in order to fulfill the task. So it always is, it has like a goal-oriented behavior, meaning that it needs to do a certain thing. And if we need to give it some examples, so we can use it for targeted automation. Let's say we need to create customer support bots, or even smart thermostat. If you want to regulate the temperature in your room, you can leverage AI agent for that. So I mentioned tools. So basically, each tool that I let the agent have, or that I create an integration for the agent, have a custom integration, meaning that it is custom. It is individual integration for each tool, meaning that it is a maintenance nightmare. Every time we need to add another tool, we need to take care of its integration. It's not standardized, and it could be a hell of a thing to manage in the day-to-day. So luckily, we have a solution for that.
And the thing is, this space evolves so quick. So when we started with the talk, we literally had to rework some of the parts because we could not keep up with the evolution out there. So we all probably heard about this MCP. So MCP is here one thing which really established, and you will see it is also something where everybody aligned to this. So think about USB ABC. So MCP, really people like this. It's an open protocol which enables us now the seamless, stressless integration of our LLM application with various external tools. So we saw, Hila mentioned this, it's bespoke when you work with different frameworks. Here we have now something which gives us the positive aspects of a protocol. So, and it's not only us who are doing this, so I made a quick social media check, and you will see people raving about this. So it's evolving in a hyperspeed. It has now security concerns. The people work on this. We see people use it to create games with the Unity engine. And there's even some people that say, like, hey, why not having an MCP server to create your PowerPoint? And I'm pretty sure it's already done because I took it in March, this screenshot.
And even our companies that we work for, Pulumi and AWS, realize that MCP is not even the future, it is the now. So it needs to get behind the wagon, or I don't know how the English term is, and they created the MCP servers to allow customers to leverage the capabilities of AWS and Pulumi in order to integrate them in the agentic workflows that we will discuss in a bit.
Okay, so let's have a look on this again. So we have now our LLM, and we see this is the pain stuff. So whatever framework you are using, because sooner or later you will see that inside your company people use this framework or this framework. The integration of the tools has to be recreated, so even if they're going to access the same tool like Jira or ServiceNow or whatever, they would need in their preferred agentic framework they want to use, they need to recreate this kind of tooling. And now comes Hila.
Did you say Jira?
We say Jira. I don't know.
Never mind.
Then I'm from Germany. We were weird.
This is first. Anyway, so if we are using MCP, then it is quite straightforward. Instead of building custom integrations for each tool, we create a standardized way for the LLM, aka the agent, to communicate with its tools. So the LLM, the agent, talks to an MCP client. The client uses standardized protocol that allows it to communicate with all the tools that it has to its disposal. And then we have one protocol, many tools. All the service providers are usually the ones to be in charge of those tools. So GitHub is releasing the GitHub MCP server to leverage GitHub capabilities, and so on. So one protocol, many tools, fun, standardization is awesome.
Okay, so now we can cross this little way we describe this. So AI thingies are actually AI agents. But,
awesome.
Yeah. And here comes my next hero, is Aval Rega, Hila, Rega.
Yeah, and the exclamation mark should be before. We changed the font just before the talk, but
yeah.
Yeah, okay, never mind. Continue.
So,
Continue.
Rega,
Rega.
Achoti. Okay.
Yes.
So now we know they are AI agents, but how are they going to communicate with each other?
Oh.
Hila.
So this leads us to agentic workflows. So if we talk about traditional workflows where we had fixed rules, we had people needed to be like in charge of it and have oversight, agentic workflows enable AI to adjust actions in real time, and it means that AI doesn't just respond, it actually participates in the process, making decisions and taking actions. And like human engineers, these agents work iteratively, collaborate, and gets better over time. So if we take like the comparison between AI agents and agentic AI agents are autonomous tools for single task execution, one thing only, and agentic AI is basically an entire workflow, orchestrated ecosystems for workflow level intelligence to achieve a certain goal. Usually it is a complex task that needs to be break down, so entire thing, orchestration that needs to be done. So how does it look like? In this aspect, when we want the agents to communicate between each other, the type of the workflow is called peer-to-peer or a pipeline. So there's the task initiation. Any agent in the workflow can get the task, basically evaluates its own capabilities to understand if it has the capabilities to fulfill the task. If not, then it does like a discovery to locate peer agents with the required skills needed to perform the task, and there's a direct negotiation between the agents. Then the task gets distributed to the relevant agent to fulfill it based on its capabilities. The execution part is now going on. The AI agents can navigate through various stages to reach the goal. It could include data collection, pre-processing, pattern recognition, whatever it is. There can also be parallel processing possible between the agents. They work independently but communicate within each other in order to see if there are any dependencies to achieve the actual goal. And then results integration, the agents have like a self-organized way to combine the results to send it back to the user. There's a final collaboration to make sure the task is indeed done. That's it, all good. Yeah.
Okay, so we're getting closer. So communication is also done. So last point, when you
No, wait.
Ah, yeah,
Finish.
okay.
Finish.
Okay, the last point we have to they communicate with each other, but now comes the point, Maze big AI boss, Achshaf. What's now with this one? So, Hila.
Yeah, so the AI boss is basically a different type of agentic workflow, which is called hierarchical. I practice this word a lot in order to say it because it's a very hard word for us Israelis. So supervisor is basically the big AI boss. The supervisor is in charge of orchestrating the interactions between the agents to achieve the complex tasks. And it could be a challenge because sometimes a complex task, especially if we talk in a free language, it needs some sort of like dissection in order to understand what needs to be done. So the supervisor actually is responsible for that. So what does it do? It gets the request itself. There is an initial task analysis by the supervisor to understand what needs to be done. There's also things of priority, urgency that it needs to take into consideration. Then it breaks down the task to subtasks, especially if it is a complex one. So it breaks it down to subtasks. It creates execution strategy or a plan and identifies the required agent skills needed to perform those subtasks. Then it assigns the tasks to the relevant agents, provides specific instructions, sets expectations, deadlines, the whole works. And since it is a supervisor, it is in charge of monitoring and coordination. So it tracks the progress of all the things that the agents are doing, manages dependencies, handles exceptions or failures, ensures sequential processing, and also resolve conflicts. And then at the end, even though, let's say, different agents had different outputs, it aggregates all the outputs to a final one that it delivers back to the client. So we saw how this, and of course, this is just like a very high-level approach. There are different types of workflows. There are even hybrid ones. So this is only that. And if we need to understand how this is actually looking in an IDP, so let's see it now.
Okay, so we're coming closer. We're leaving now the whole robots, Futurama stuff and say, okay, I kept still one of the icons, but how does it look like in a real life? So we call this now the IDP multi-agent system. User, still the same. Now the user comes to the first layer here in this new system called the planner layer, where we have our supervisor agent. Again, you can spin this up, you can have hierarchies of supervisor agents also, but the supervisor agent takes the request and looks, and because it's backed up by an LLM also, it makes, like Hila said, the first analysis and so on, cuts the thing in pieces, and gives the task, the subtask, to a specific agent in his agent layer. Again, you define them depending on your states to say, okay, I have an IAC agent, and now comes the interesting part with the MCP, our tooling layer. They are all backed now with real integrations to system. kubectl, Helm, whatever you want, it can be accessed from the agent doing the task, and now you see left, right comes in, right, left comes everything back. If the supervisor is d'accord with the results and the output, he goes to the user and says, I'm done. If it's not d'accord, he's like, bro, can you work on this again? So.
Awesome. So this is not just a diagram, this is something that we started implementation just for you to get a grasp of how it looks like. So we have a demo for you. So what are we gonna see in the demo?
And Hila put on the notes, he's put, if we are on mark 14, hurry up, so I need to hurry up. Are we good?
We're good,
so,
we're good.
Okay, we used for our demonstration here, we used Flowwise, which is a low-code, no-code platform where you can create agentic workflows. That is very crucial for us here. You could, of course, use a different framework which supports this supervisor flow. We use Bedrock, and one of the models of Bedrock, Pulumi, of course, we're going to deploy infrastructure, and then a Git system here, GitHub. So we go in details. Oh, sorry.
Yeah, this is how it looks like. Don't worry, we will see it in depth in a second.
Okay.
So
let's go. Okay, this is the Flowwise UI. On the left, we have some properties to say we are interested only in the agent flow, so we created the PlatforMa agentic flow, and now we come back to the graphic you saw in the beginning. Let's zoom in. Let's start with the supervisor. So supervisor is set up, has a memory to remember any state, and now we connect our chat Bedrock system to it with Anthropic Cloud 3.7 because we are technical, we need this. Important part is to let the supervisor know who you are, what you're doing, and giving him some clear instructions. So prompt engineering is not anymore a joke word, it's really something we need to be clear of it because otherwise the results are rubbish. And here we go to our worker. So this is one of the sub-agents. Again, it has a definitive system prompt, like who you are, and now what is the expectation, who's going to call you, and how to respond when you're finished with your task to the supervisor. We made this up, you probably create better ones. And again, backed by LLM, and here we see now the MCPs connected to it. So I attached now the selection of MCPs I think the agent needs to fulfill his task. So we have a Git MCP, we have some file manipulation MCP, and so on and so on. So you are completely up to, you can even write your own MCP if it doesn't work. Here's the Pulumi one. Again, he's probably working better than I will do ever, because it's much smarter than me. So Pulumi agent, and you are doing this kind of stuff. And then again, backed by a LLM, in this case, again, Bedrock, and then an MCP to it. And now we have the Flowwise. We can interact with it as a chatbot. We send the prompt. The prompt is actually the golden path that we define, that how does it look like to perform this task. In this case, the task is create a static website in S3. That's it. So we define the template, as you can see here. It is very generic, but inside we have a section of, now we don't want just a static website, we want our static website. And you will see that we have one which is called Hello PlatforMa. Okay, so we have our files, and we say, hey, please use those files in the prompt as well in order to integrate everything together. So we send it to the supervisor. Supervisor gets it, it runs it to understand what needs to go on, and then you see that the entire prompt was very, very big, but it sends to the GitHub agent only the section that is relevant to the GitHub agent. That's it, because it was able to dissect it and know what needs to be done by the GitHub agent specifically. So it runs it now,
And once it is finished, you see the outputs, and then entirely at the finish, it's success. That success is what the agent sends to the supervisor to tell him that it's done, and you can continue to the next level, next step.
Yeah, and now we see the result goes back to the supervisor. Supervisor happy, everybody is happy. Now he goes to the Pulumi agent with the output from the agent before to the Pulumi agent. Now the Pulumi agent does the magic, run the stuff, and so on and so on. And we can see now the most important part, the Pulumi agent returns now the temporary or the URL to the website. And then you see that's the final output of the supervisor. You see the output is differently, and most importantly, it gives you back the public URL, because that's what part of the golden AI path we created. And yeah, hello, platform 24/5.
Meaning we didn't download it from the internet, we actually created it. Okay?
Yeah.
So that's it. And of course, this is just to pique your interest, to see how we can do it, how we can incorporate AI capabilities in an IDP. This is just like one task that an IDP can allow a user to do. But from here, the sky's the limit.
Okay, so we are sadly, or happily, depending on how you see this, we are now at the end of our talk. So in good AI tradition, we also want to generate our talk summaries. So we ask now, hey, takeaway bot, can you give 4 key takeaways? So first one, and I think that should be now clear because I emphasize and we emphasize all the time, AI is here to stay. No doubt about this one. And this is the first point, I believe that agentic AI is the way to go. There's a reason why a person, I think it was Salesforce, coined agentic AI as the third wave of AI. So that's the thing. We know generative AI was before and all the stuff. Agentic AI is the way to go. You saw the examples.
Yeah, so basically the question isn't if we should leverage AI in our platforms, but how to do it right. So agentic workflows can and should empower IDPs. AI can transform from a buzzword that it currently is to a practical tool for platform engineering. And it's not, and don't just add AI just because we can, but in order to really build an agentic system that can make our platforms more efficient, our developers more productive, and of course, our operations more reliable. So the future of IDP isn't just about automation. It's about intelligence, autonomous systems that can think, act, and learn. And I would say the opportunity is here. So please go home or to your office and try it out. But even as a POC, if you don't know what to do or what you want the agents to do, don't expect the agents to know. So define it clearly, and when working with AI and LLM specifically, the prompts are very, very important. It's called prompt engineering for a reason. So refine your prompts, do iteration for the process in order to make sure that whatever you're trying to achieve is indeed achievable. So we gathered some references for you to take. If you want to scan it, this is now. So we collected a lot of materials, both theoretical, but also links to tools that you can actually leverage. There's inline agent for Amazon Bedrock. There's Strands, which is also an open SDK that just released 2 days ago because the rhythm here is crazy with how it gets progressed. So we think that these references could help you in your journey of augmenting AI in platform engineering.
And of course, and this is the point where also for my employee that he doesn't say Engin, lama ata tamit be Tel Aviv. So yeah, I'm here for you folks. So please join our first Pulumi user group hosted by the good guys at Lemonade. So they opened the office. And our CEO will be also there. So if you are Terraform, hardcore, diehard, whatever, you have the opportunity now to talk to the founder of Pulumi. So feel free to join on Meetup. And if you want to see us again, we will be also at the AWS Summit. We have a booth, and
I'm just going to be there because I'm an employee.
Yeah,
so
you are there.
I'm going to do a lot there, in the booth and stuff. But yeah. So that's it, what we have for you. Thank you very much. If you have any questions, feel free to catch us after the conference, basically. And that's it. Thank you very much.